Hello everybody. Let's look at it. What is bitwise ones complement and its importance? What is bitwise? First let's understand what is bitwise. So we know already that computers understand everything in terms of zeros and ones. So the only thing they understand is 0 and 1, and then that 0 and 1 makes up something different. Let's say you have you know, a if you have a sentence, this is a nice screen, let's say, right? So computer would not understand this in the same way you and I understand the English language. It may actually turn out to, understand the same sentence. This is a nice screen by reading 1 1 0 1 1 1 1 0 0 0 1 1 1 0 0 like this, all these zeros, ones, zeros. So all this number will will actually make that sentence. So when we speak in English, computers don't understand English, or if they understand, even if they want to understand English, they only understand in terms of numbers. So, okay, if that is the case, then what that had got to do with the bitwise complement? Okay, because we have already understood that the computer understand everything in ones and zeros, and you are given a number like this, right? If you are given a number like this, you could bitwise, means bit by bit, this guy, this guy, this guy, this guy, this guy. For each bit, if you flip it means reverse it. So 1 becomes a 0, 1 becomes a 0, and 0 becomes a 1. This is how it works, right? And that process of flipping the number is called bitwise ones complement. Now, okay, this sounds interesting. You would say, okay, so I can make a 1 into 0 and 0 into 1. So what? What does it give me really? Yeah. So let's understand what does it really give us. So for that, what we are going to do is let's take a number a, which is 12. A number is 12, and in binary we will call that number as, how, we will say 1100. Now if you don't know how that, why, how come A12 is binary 1100. So the way it goes is, and you, if you recall your binary math, the first bit on the right side is the 2 to the power 0, and then this is 2 to the power 1, this is 2 to the power 2, this is 2 to the power 3. If it is 2 to the power 3, that means it should be, it's 0, 1 and 2. 2 means, so this one, the one here, is actually 4, and this one here is actually 8. And if you add this plus this, you got 8 plus 4, which is 12. So that's how you get the number 1100, right? 1100 as 12. Now you have another number. Let's say b equals 10. So binary for 10 would be 1010. Okay. Suppose we can do certain operations with this, right? If we do a and b, a and b means, what does it mean? A and b. So now this is another, this is a type of a bitwise operation, in which one this a guy here, this a guy here, and this digit here, they are both ANDed. ANDed means, and is an operator where a and b both have to be 1, then you will get a 1. If a is 1, like in the top number, and b which is 0, then you are going to get 0. And if this is the second one is A is 0 but B is 1, right? So what do you do here? You basically say, look at this thing. So this is 0, this is 1, and this becomes actually 0, right? Whereas, so this becomes 0. And if you look at the last one, right? Last one you have, this is 0 and the B is also 0, correct? That means it is going to become also 0. So A and B will get you 100, which is 8, right? I remember I told you 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. 2 to the power 3 is 8. So this becomes a number 8. Okay. So this happens, this is a binary ending of two numbers. What did we do here? We basically, let me clean it up and let me write once again just so that you understand. First number is 1100 and the second number is 1010, correct? And then how do you do it? You look at the each bit you look at what is the number. So in this bit, if you look at this bit, right, if you look at the left of this one, right, so both are ones. That means you are going to get 1 here, and the now you remember, right, 10 0 0 1 0 0 0 0. So this is how bitwise AND operation works. Now let's look at OR operation. What is the bitwise OR operation? So we are going to take the same number A equals to 12, which is 1100, and B equals 10, which is 1010, right? And now if you OR it, OR means either the top this bit or this bit, as long as either of them have the 1, then you get a 1 here. In this one, if you see that both of them has 1, so you got 1. In this one, you see this is 1, this is 0, but because one of them has 1, so it becomes 1. And then this one in the bottom one is 1, so it becomes 1. In the last one here, you have both zeros, so you get a 0. So A or B will give you 11100. So this is how each bitwise AND or bitwise OR operation works. Now if we want to look at certain other things, right? For example, let's say if I want to shift the bits, right? I want to shift I want to make it XOR, right? Bitwise XOR. So bitwise XOR, what would happen? Let's take it 1100 and then 1010. XOR means reverse of OR. OR means what happens if you have whenever you have A and B are differing. So this is 1, this is 1, so you're gonna get 1. This is 1, this is 0, so you're gonna get a sorry, let me clarify this thing. Hold on just a moment. This is if the both of the digits are only the bits where A and B differ differently. Both of them are two are different things. For example, 1 and 0, they will become 1. This guy will become 1. This guy will become 1. This guy will become 0, and this guy will become 0. So basically, what you want to understand from this thing is bitwise operations means you take a bit, any bit, right? And you do operation on that bit. either this bit, or this bit, the last this bit and this bit. Okay, so this is how the bitwise operation works. And if you have any still questions, you can always come back, ask me in the comments, and I'll try to explain these things further away. Till then, till for the next time, take care. Goodbye.